This is a 2016 Ford Flex. It offered a twin-turbo V6, adaptive cruise control, a second-row fridge, even automatic parallel parking. Pretty much everything you'd expect to see in a Ford back then, except you could not get lane-keeping assistance. The Flex was actually the last Ford that never offered lane-keeping at any point. But why? Being on the same architecture as the Taurus and Explorer, it fell between the two, both in size and price. Most lane-keeping systems follow the same basic design. You have a small camera mounted to a bracket, mounted to the windshield. One camera can fit multiple windshields simply by changing the bracket. That's what Ford was doing back in the early 2010s, and have been doing since 2018. But between these two, for some reason they decided to make the camera part of the rearview mirror. So now instead of having different brackets for different windshield angles, you needed to change the entire mirror assembly. And that's where our issue comes in with the Flex. Its unconventionally boxy design meant it would need its own specific mirror. While its platform siblings could all share one mirror design, on a Flex that design would point at the hood instead of at the road. So why didn't they make a different mirror that does fit? Well, they did, for the F-150 in 2015. But by that point, Ford had given up on the Flex. It was not selling nearly as well as they had hoped. Really, the only new feature between a 13 and a 19 was the heated steering wheel, which they just pulled from a Taurus. So let's do what Ford didn't do and put lane keeping on a Flex. This will also enable automatic high beams and the completely useless driver alert system. I've designed everything to fit the limited trim. It could probably be adapted to fit the SEL, but those have the rear view mirror mounted lower, right where I'm putting the camera. And maybe it would work on the SE, but I don't know if their instrument cluster supports it. If you want to try on one of these, let me know in the comments if it works out. I'm genuinely curious. It is at your own risk though, because I've broken numerous windshields trying different designs. So first off, we're going to need some tools and supplies. I'll have a full parts list in the description, but for now the important bits are a lane assist mirror, wire and soldering equipment, a connector crimping kit, I'm using JST SM connectors, Oracle 651 permanent vinyl in matte black, JB Weld steel reinforced epoxy, Sika 207 glass primer, foam brushes, a mirror mounting bracket, a momentary contact push button, an OBD-Link EX with a 4-scan extended license, either an OBD2 splitter cable or an APIM extension harness, and the big one, a 3D printer that can handle ASA. I was hoping to make this possible on a stock Ender 3, but ASA is going to require an all-metal hot end. I've also got this little buddy hanging out with me. The main reason this project has taken me so long is this mirror bracket. You cannot buy these from Ford. They come pre-installed on the windshield, you have to buy the whole windshield. Since lane keeping was never an option on the Flex, there is no Flex windshield with the bracket pre-installed. At least in my area, you're not going to find one at the junkyard either. But thankfully, there are reproductions available on AliExpress. And I know what you're definitely thinking right now. Why is this in the parts section? Why can't this be 3D printed? Well, there's really not a lot of material for the mirror to grab onto. These mirrors are heavy, poorly balanced, and the bracket is in constant tension. It pretty much has to be made out of cast metal in order to work. I did make a model of it, or at least as close as I could figure if someone wanted to try making one in a home foundry. Let's talk about what kind of mirror to look for. The second hardest part of this whole project is finding the correct mirror. This is my best guess on compatible donors. 2013 and newer Taurus, MKS, and MKT are all fully compatible, as well as Explorer between 13 and 15. 2013 through 16 MKC, as well as 2016 and newer Explorer, are physically compatible, but will need the firmware downgraded. I don't know if the newer MKC mirrors will work. These introduced the Copilot 360 features like stop and go, automatic emergency braking, and pedestrian detection. I can't guarantee that the Taurus firmware can be flashed to these, and I really don't feel like buying another mirror just to find out. Let's head over to eBay and search for 2016 MKT rear view and filter by used condition. First step is to ignore the listed donor vehicles because it's usually wrong. This came from a Fusion, not an MKT. This came from an MKZ, not a Focus. Focuses only used that earlier camera design. No matter how many times they say, with lane departure, this large D-shaped sensor is Auto-Highbeam only. From the front you can tell it's just a light sensor. A proper lane-keeping mirror will have a small, circular lens and AHBC/LA stamped in the body. If it also says RF, it's the newer Copilot 360 mirror. Moving on to the aluminum body, there's 3 major styles. Long body has a large gap, centered notch, and symmetrical holes. Medium body has a smaller gap, offset L-shaped notch, and asymmetrical holes. Short body looks almost identical to medium, but this gap is even smaller. The L notch is right up against the camera. And finally, we need to check the camera. Taking a close look at the camera assembly, chances are the lens will point straight forward and the body will be square with the feet. If the lens points downward and the body is offset a little higher, the mirror came from an MKZ and won't work. Older mirrors have these little dimples in the camera, but they seem to work just the same. My design is based on the medium body, which is thankfully the most common. These are the 3 mirrors I've tried so far, and all 3 were made to work. Alright, so what's the deal with the MKZ? Back here, I said it was compatible. Then here, I said it won't work. Then 2 seconds later, I said it did work. Well, it's kind of up in the air. All of my previous designs had a printed spacer between the camera and the aluminum. The MKZ's camera just needed a slight tweak to that part to work. Since my current design doesn't use a spacer, I can't easily accommodate the MKZ camera. So now I'd have to prototype and test an entirely new adapter and cover just for the MKZ, or figure out an angled spacer without hitting the windshield. Maybe I'll figure something out in the future, but for now just don't buy an MKZ mirror. So now we get to go over the 3D printed parts. This is what Actually, you know what? I'm not done with this yet. I don't understand why this MKZ variant exists. The 3 aluminum body styles correspond to 3 common windshield angles. Long body is on Fusion and Edge. Medium body is Taurus, Explorer, MKS, MKT, and MKC. Short body is F-Series and Continental. These all share the same straightforward camera module. The Fusion and the MKZ have the same windshield angle, so you'd think they'd use the same mirror. But for whatever reason, the MKZ uses the Taurus style mirror and a unique camera that's angled 5 degrees downward. I mentioned before that the Flex wasn't selling well, but neither was the MKZ. If they could make a one-off camera for the MKZ, why not do the same for the Flex? They're already making a limited specific windshield for the rain sensing. There was nothing stopping them from attaching the correct mounting bracket, making Auto-Highbeam standard, lane keeping part of the 301A technology package. But they didn't, so that's why we're here struggling to stick a camera to a windshield. So now we get to go over the 3D printed parts. This is what Alright, and you know what else? I'm just kidding. This is what I get to be proud of. First and most important is the retainer adapter. This is what makes up that 8.5 degree difference between a Flex and a Taurus windshield. The rotation lock has 2 jobs. First is providing a flat surface for the screw head since we changed the angle of the retainer. Second is a tab to prevent rotating the mirror too far. Normally this L notch on the aluminum body does that, but we're kind of floating above it now. There's a lower cover, not really sure what that does. The camera trim is supposed to be a glare prevention measure, but it doesn't really do that here. It's purely decorative. An upper cover, with or without provisions for a push button. A rain sensor cover. A template for the bracket. A template for the vinyl with an alignment extension. An adapter for the mirror wiring harness. A tool to remove the factory mirror. And optionally, a couple gallons of prototypes, old designs, and failed prints. I mean, I kind of wish I didn't have to use so many different types of filament, but it's kind of out of necessity. The adapters have to be in ASA because PETG cannot support the weight in direct sunlight. Trust me. The covers should be in PETG because I don't have a lot of luck getting it to print something this big and thin in ASA without it folding up into a pretzel. The templates are in PLA because PETG and ASA don't like printing large flat surfaces without curling or shrinking. If you can print it all in ASA, then hey, thumbs up, but I already have enough failed prints doing this the easy way. While this print's in the background, there's a couple minor points for the settings. Retainer adapter needs to be dense, 8 walls, 50% infill, whatever it takes to make it as strong as possible. The lower cover should be opening down. It doesn't need supports at the peak, just the edges. The Z-seam should be along the front, not the bottom. For the covers and the camera trim, I like to use the fuzzy skin setting with a 0.1 distance and 1.25 density. It helps hide the layer lines and make it look a little less like something I 3D printed in my basement. Printing the rain sensor cover on its side helps with the finish. Okay, nice pile of parts to clean up. A deburring tool does a good job of removing the brims. You'll see a recurring theme here where the camera has no idea what to focus on. So, remove supports and clean up the edges, the usual 3D printing stuff. Now we can start assembling the mirror. The retainer clip needs to come off. It's held on by a T25 screw. These two holes need to be tapped to a 632 thread if they aren't already. Retainer adapter takes the place of the clip. The retainer clip is placed back on, pushed into the alignment grooves. I gotta make sure both of these are pressed nice and flush since ASA has a tendency to shrink slightly. Rotation lock goes on top with the tab facing down and up, or up and down. I'll start a 1032 by 1 inch screw in this central hole. Once that's started, 632 by 1/2 inch screws in the two side holes. Everything gets tightened down. Let's test fit the mounting bracket. It should be pretty snug, but not too snug. See, now this one is definitely too loose. I have no idea how it got to be that bad. We might have to bend these tabs a little bit if it's too tight or too loose. If it's taking too much effort to remove, it's easier to loosen the 1032 than wrestle with the mount. Camera trim slides into the channel on the lower cover. I'll test fit everything to make sure it feels good. It looks like I need to make a couple minor tweaks to the camera trim design. Either way, let's take it off and do a little wiring. Wiring is thankfully pretty straightforward. We need power, ground, CAN bus, and a lane departure switch. We'll get power and ground from the Flex's mirror harness. We have a couple options for the CAN bus connection. I could tap into the backside of the OBD2 port, or use an OBD2 splitter cable, or an APIM extension harness. The lane departure switch just needs to momentarily ground out the lane departure wire coming from the mirror. While it can be installed anywhere, the upper cover is the obvious choice. I could also swap in the dual stalk controls from an Explorer, but that's a little pricey. I tried making an adapter for this connector, but it was too bulky and the pinouts aren't consistent. Cutting it off is a lot easier. I tried recording this multiple times. It is a lot harder than I thought to work around the camera while making sure it's in focus and that my hands aren't blocking the view. I'm damn near out of harness to work on, so you're gonna have to get by with this rough demonstration. The purple wire is power. I'll extend this another 6 inches or so. Both black wires are ground. These will get joined together with 2 additional wires. Power and one of the grounds will pass through the adapter. I'll crimp male DuPont pins to these. Green with an orange stripe is the lane departure switch. This and the other ground get crimped to a JST connector. White with a blue stripe is CAN bus high, white is CAN bus low. These will go to another JST connector. To keep from mixing them up, I'm going to use a 2-pin for the switch and a 3-pin for the CAN bus. Well, on my actual mirror I'm going to be using a different connector for the lane departure switch, but you won't see that till the next video. Any leftover wires will get capped off separately. They're for features the Flex doesn't have. Lane departure switch gets a couple inches, and a JST to match what we did before. Alright, great. The mirror wiring is done, the heat shrink is heat shrunk. I already have the CAN bus wiring installed in my car, so there's no demonstration on that. It's a twisted pair, down the A-pillar to wherever we're tapping into the CAN bus. Use your imagination. Alright, this looks like a pretty good stopping point. In the next video, we'll go out to the garage and actually install this in the car. Future videos will include calibration, downgrading the firmware on an MKZ mirror, and any mistakes I've made. I'll also showcase all of my old failed attempts, including the most recent one where I actually had the installation completed and the video 95% edited before I scrapped it all. A good chunk of this video was actually reused assets from that one. Most of the failures occurred on days that exceeded 100 degrees Fahrenheit, and it looks like this outside right now, so it might be a little while.